Consider this level with a simple puzzle. There's a passage on the left, a passage on the right, a door, and a terminal. The player can use the terminal to open the door and unlock their path forward. However, if we initially enter this level from the right, we won't be able to solve the puzzle and go to the left. I'll be referring to levels like this as directed from left to right, meaning that in their initial state, we can traverse them only from left to right. Similarly, a level like this would be directed from right to left. And this one would be bidirected. We can traverse it in both directions. In a semi-open world, directed levels can be used sparingly to improve exploration. For instance, let's make this level directed from right to left. Now the player won't be able to pass through it. They'll have to explore the green area first, and once they reach the other side, they'll be able to unlock it as a shortcut. In Astortion, the majority of levels will contain puzzles, making them directed. And this can be really problematic when designing an open world. Take a look at this example. The player will enter here. There's a point of interest in the level below. Say that we want to have puzzles in these two levels. Which way should they be directed? Something like this will force the player to go clockwise. The opposite will force them to go counterclockwise. In both cases, the player doesn't get to choose how they want to explore this section. The only remaining solution seems to be something like this. Now the player can go either left or right, but after solving one of the puzzles and reaching the point of interest, they won't be able to go back through the opposite side. They'll have to backtrack. And then the other puzzle becomes useless. The player can safely skip it without missing anything. This is a very simple example, but it illustrates the main problem with too many directed levels. They either force the player to explore the world in a specific order, or they cause unnecessary backtracking. The obvious solution here would be to use bidirected puzzles that can be solved from both sides. Make them symmetrical, with the puzzle always being duplicated on the other side. Or make them work like arenas. When the player enters, all passages close, and they open only after the puzzle gets solved. Unfortunately, this puts a lot of restrictions on our puzzle designs. For instance, can you think of a way to make this puzzle solvable from both sides? That's why today I want to focus on a different solution. Instead of trying to design one bidirected puzzle, let's create two variants of the same puzzle, directed the opposite ways. At the start of the game, it's unclear which one should be used. But the moment our player enters this level, the game will use the entered passage to pick the best variant. And this variant will then be used for the rest of the game. From the player's perspective, everything seems normal. They simply explore a constant world. But under the hood, the game dynamically adjusts itself to make this exploration smoother. If we go back to our previous example and apply the same idea, you can see that the player can now choose which way they want to go, but they no longer need to backtrack. I call these Schrödinger's levels because I think it nicely encapsulates the idea of the level's contents being unknown until we take a peek. But it's worth noting that there's no randomness involved here. Knowing which passage results in which variant, players can easily predict what their world's gonna look like. And even though randomness could be introduced here, I wanna keep Astortion speedrunners friendly. With that out of the way, let's look at how I implemented this. I'm gonna use our good old test world as an example. It consists of 4 scenes connected in a circle. Only this time, I've created 2 variants of scene C. If the player enters through the door, we want to use this one. And if they enter through the hole in the ceiling, we'll choose the other one. In one of my previous devlogs, I showed you my world graph editor. It was a tool for managing connections between levels. This is its upgraded version called Cartographer. The underlying idea is still the same, but the new version is closely integrated with Typewriter. Each scene handle is now a table, and each passage is represented by a fact inside this table. I can still use the node editor to edit connections between them. But the most important change is the introduction of a scene rule. This table, for instance, has only one such rule, and because of that, whenever we enter any of the passages, the specific Unity scene will be loaded. But let's go to the table for scene C. Here we have 2 rules, one for each scene variant. And now, just like with dialogue rules, I can define the criteria that need to be met for this scene to be selected. For the first variant, I'll simply use the current passage fact to check if the player has entered the door. Okay, let's test this out. First, I'll enter scene C through the door. As expected, we ended up in the first variant. I'll restart the game and this time enter through the hole. Now we're in the second variant. But notice what happens when I leave through the door and then return. We're still in the second variant, even though we entered through the door. This is thanks to the Modification tab. Here you can see that each scene rule sets the resolved scene fact to itself. This ensures that once a variant has been selected, it will be used for the rest of the game. Of course, Cartographer can do much more than that. Because every passage is also a fact, we can use them to dynamically change the dialogue. This line, for instance, will only be said if we've entered the current level through the hall. I can also check which scene variant we're in, or which area. Similarly, when declaring the criteria for a scene variant, we can use any facts we want, not just current passage. Imagine that at some point in the game, one of the corridors should collapse. We can simply create a fact for that, and make Cartographer load the collapsed version based on it. But I digress. One final note, I've been using examples of scenes with only 2 passages to make the video easier to understand, but this concept scales up to however many passages are needed. Though instead of saying that the entire level is directed, you'd need to think of it as a directed graph, where passages are the vertices. Anyway, if you wanna know more, I'll be streaming next Saturday, links in the description. Thanks so much to all my patrons, thank you for watching, and until next time.